Today we're going to install an air horn on my Victory cross-country tour. Follow the link at the bottom of the screen and it will show you how to remove the fairing, and then we'll get started. The stock horn is located up in this corner behind the plastic chin cover. We have four 4mm hex screws, 2 up here and 1 on each corner down below. So we'll take those off. Now that we have the 4 bolts undone off the cover, how I remove it is I kind of push it in and slide it over, giving me access to this side in order to pull it out. Now that we have things apart, let's go talk about the horn. We're going to talk about some issues, namely something called back EMF. We're going to talk about it and we're going to figure out how to get rid of it. The horn that I'm going to put in my bike is the Wolo Bad Boy. I picked this up at a local hardware store in the States, and it comes with a self-contained air horn with the air compressor and the horn built into one module. It also comes with a nut and bolt, some instructions, and a relay. A lot of people are confused about what a relay is and how it works, so I'll explain this to you. It's a very important device. A relay is simply an electromagnetic switch. It has a coil of wires, and when you apply power to it, it closes the switch. When you release power, the switch opens up again. The electronic symbol for a relay is something like this. You have your coil between pins 85 and 86. When you apply power to it, 12 volts on one side, ground on the other. It doesn't matter which way in this case. When you apply power, 12 volts and ground, this becomes a magnet pushing these switches together. So power can now flow from pin 87 to 30 or vice versa. When you release power, the magnetic field collapses and the switch opens up. The best way to hook this up is to have your horn switch connected to one side. When you push your horn switch, you are applying 12 volts to one side. We will ground the other side, and this will create the magnetic field, closing your contacts. We will have 12 volts from the battery on one, and the other side will go to your air horn. So when you press the button, energizes, closes the contacts, you get 12 volts directly from the battery up to your horn sounds. When you let go of the button, collapses the magnetic field, and the switch opens and turns off the power to your air horn. This is a diagram of the pin configuration underneath. 85 and 86 are the coil. 30 and 87 are your switch. Very simple design, but it also has a problem. When you apply power to one side of your coil, it creates a magnetic field, causing your air horn to go off. When you release the switch, you are cutting off the power to the coil. However, the coil, because it has a magnetic field and it collapses, it induces electricity into the wire. Most people who've hooked up an air horn or some other third-party horn on their Victory motorcycle, they have noticed when they push the horn button and let go of it, they get little indicator lights flashing just for a second. They'll just flicker. Your cruise light or your signal lights or something will flicker just for an instant. And this is caused by the collapsing magnetic field of this coil, because the power of the collapsing field has nowhere to go, so it goes down your circuits of your bike. It lights up your lights just for an instant. But it could also cause problems. It could also produce power going back into your ECU or somewhere else. And this could be much higher than 12 volts. This could be in the neighborhood of 40, 50, 60 volts or something like that. There is a way of getting around this. The easiest way to get rid of the electromagnetic force that's being fed back into your circuitry, or back EMF, is by using a little device called a diode. This is represented by this symbol here. There's an anode side and a cathode side. How I remember it is anode looks like this. It looks like the letter A. So that's the anode side. The bar is the cathode side. Its purpose is to allow power to flow in one direction but not the other. It flows in this direction, and that is, how I remember it, is by this little arrow shape right here. Being an arrow shape, it goes in that direction. On the diode, I don't know if you can see it, but one side is a gray bar. So it looks like a black device, and it has a gray bar painted at one end. That is the cathode side. That is this side. Okay? Power will flow in this direction, not in this direction. Now, the idea of this is to place it in parallel with the coil. So we want to solder a diode right alongside the two connectors between the coils. Now, so in fact, we are going to put it right like that. Now, you remember before, I told you when you applied 12 volts, you were able to put it in any direction. 12 volts here, 12 volts there, it made no difference, it was only a coil. However, now you've put a diode in there. And as you know, a diode, power travels only in one direction. In this case, it goes up. If you were to put your 12 volts down here and your ground up here, power would simply go through the diode directly to ground and short out. It wouldn't even go through your coil. You would blow a fuse. So in this case, you must have your 12 volt power on your cathode side. You must put 12 volts on this side of your diode. You don't have a choice. If we were to hook up a diode and solder it between the two pins, between this pin and this pin, and we put it in that direction where the cathode is on the right, then you must put power, 12 volts, here and ground here. You have to do it that way. What happens now is when you do it this way, 12 volts will not flow through the diode. It will energize the coil, closing your contacts. When you release the 12 volts from your switch, the power will now go through the diode and the coil and cancel itself out and will not produce any back EMF into your system. I'm going to place the diode as far back as I can because you need room to attach your connector onto the pin here. I'm going to bend the diode arms down, and I'm going to put a drop of solder on them. I'm going to use a low wattage soldering iron. This one's only a 30 watt soldering iron because the gun, which has like 100 or 150 watts, will be too hot for it and it might damage the internal of the relay. Remember, it doesn't matter which way you put the diode, but your positive side has to go on the cathode end of it. And now I'll simply cut off the extra ends. So this is what the relay should look like with the diode attached. Sorry about the fuzziness earlier, but you get the idea. I cut some of the tie wraps that was on the wiring just to move them out of the way. I'm going to place my horn right here on top of my radio. I went to the local hardware store and I picked up this little piece of metal. The holes weren't quite in the right place. I had to enlarge the top hole. That'll be for the big bolt for holding the horn on. I'm going to use an existing hole and I'm going to bolt it right here to the bottom hole of the radio, and I had to drill another hole that matches the top hole up here. So I'm going to mount it like this. I crimped on a spade connector, one on each wire, the red and the black, and connected it underneath the horn before bolting it on. It just of course made it easier to get onto it, and I'm going to cut and place these later. As I say in all my videos, there's 100 ways of doing things. You can literally put your horn anywhere on this bike. You can put the relay anywhere on this bike. For me, I like keeping everything centralized. I like putting all the wiring, all the mods, all the attachments inside the fairing. It's just more room to work with, easier to work with. Your power used to trigger the relay can come from anywhere as well. I could follow the wiring from the horn button into the wiring harness over here and tap into it to trigger my relay, but I don't want to cut into those wires. So what I'm going to do is the original OEM wires that are down where my horn is, I'm going to use that. I'm going to unplug the two wires from the horn. I'm going to leave the horn there. I'm going to unplug the two wires. I'm going to put a test light on one wire. I'm going to push the horn button and see if it lights up. If it does, that's the power wire. That's the only one I need. I don't need both wires up here. So I'm going to run that power wire up here using quick connects. Just simply tap into it down there, run it up here, and that will be going to the cathode side of my relay in order for my trigger my horn. I removed my horn and unplugged the two wires from it. There's a gray and a black. I have a test light lying on top of my battery, grounded to the negative side of the battery, and then I have my positive side going through a jumper to a paper clip, and I've got it hooked onto the terminal of the gray wire. I'm going to turn on the accessory unit of my bike, and I'm going to press my horn button. As you can see, the gray wire is the power wire for the horn. So that's the one I'm going to tap off of, and I'm going to feed it up to my relay inside the fairing. So I tapped into the existing horn wire with 20 gauge wire. It doesn't take a lot to trigger a relay, so I just used 20 gauge. Plugged it into the cathode side of the diode, if you remember. And then the other side is ground. I hooked it up to my ground terminal post here. Then the positive side of the horn goes to one side of the switch of the relay, and then the other side of the switch goes into my fuse block over here, my auxiliary fuse block, and I put some heat shrink around the ends just to protect them. Oh, I labeled horn on the relay so future civilizations can know how this was done. Also, Wolo sent me this really cool bad boy on board sticker that would look great right here on the windshield. No. So that's it. It's all put back together. Let's take this outside and we'll show you the difference between the stock horn and the new air horn. Well, that's it. I like it. Sounds really good. I'm hoping it's going to get good attention on the road. Thank you very much for watching. Have a good day.